Welcome to Heavy Networking, the flagship podcast from the Packet Pushers Podcast Network for IT professionals. I am Ethan Banks, your co-host for today's episode, and with me is Drew Conway Murray. You can follow us on LinkedIn, Blue Sky, and the Packet Pushers Community Slack channel, and please do. As has been brought to my attention several times recently, I am a seasoned network engineer, and WAN provisioning back in my day was a problem of lead time. How much time would elapse between ordering a circuit and that circuit going live? And that time delta factored into the project, and it sometimes drove decisions around providers. In the case of today's sponsor, turning up a new WAN circuit takes about a minute. Megaport is our sponsor today, and in our conversation with CTO Cameron Daniel, we discuss the global WAN architecture, POPs, use cases, cloud routers, and more that Megaport makes available. And if you think of Megaport as simply a cloud connectivity company, they do far more than that. It is more accurate to describe Megaport as network as a service. Now, if you like to wear your networking, Megaport has a t-shirt for listeners based in the US. Visit megaport.com/packetpushers to claim yours with promo code packetpushers. That is megaport.com/packetpushers, all one word, with promo code packetpushers. Cam Daniel, welcome to Heavy Networking. And I don't think Megaport's been on the show before. So would you, in a nutshell, tell us what Megaport is all about? This is the elevator pitch, just a few sentences.
Sure. Yeah, no, I don't think we have been on the podcast before. So Megaport's a network as a service provider, like you said. We operate a global network, and you can connect to us in over 930 data centers across 26 countries. We're a bit like a traditional telco, except our network is fully automated, and customers can order circuits via our portal, and they're delivered, as you said, in less than a minute. We're one of the largest connectivity partners for most of the major cloud providers, like think Direct Connect, ExpressRoute, Google Cloud Interconnect. But as you said, we also do a lot more.
So I think a lot of people think of network as a service as primarily about cloud connectivity. And yes, you do that, but do you do more?
Yeah, definitely. One of the things that I think people misinterpret about Megaport is that they think we might be like some kind of overlay network, but we are a lot more like a telco than you'd probably think. We have network in data centers. We've got switches and routers racked and stacked with servers in, as I said, we've got access in over 930 data centers around the world.
Yeah, you gave us a test account, and I was just working with that before we started recording here. You've got the big globe diagram in there, and I can drill into my geographic location from that. And I live in the northeast of the US, and there's a bunch of data center options in Boston and in New York City and in Montreal and in Toronto and so on. And I actually stood up a couple of cloud routers in Manhattan, one at Digital Realty and one on one of the Equinix data centers, and connected them up. It was just a couple of clicks, honestly. And it said waiting for resources. As soon as resources became available, boom, there it was.
That's good to hear. That's what we like to, that's what we do.
I mean, it's interesting that you say like we're more like a telco, which isn't necessarily a comparison people might want to hear, given their relationship with telco. So what do you mean by that?
So basically, because we operate a physical network, so it's kind of a bit of a long history. So we originally built the network to deliver cloud connectivity to enterprise customers and data centers. Like it was a bit of a niche that we kind of like started working on back in 2013. So the idea was to build a network and let customers consume it just like they consume their cloud services, because that was kind of the rage at the time. So on-demand networking, no contracts. The products were, and they still are, kind of modeled around similar to cloud services, so building blocks that you can stack up in different ways to create solutions based on what your network needs. As we kind of expanded around the world to support the growth of the hyperscalers, because we work very closely with them, we realized that we like accidentally built this like homogeneous, totally automated network that spanned all these countries. And so we figured out how to productize that as well. So now customers can spin up completely on-demand point-to-point circuits between any of those data centers, as you've seen, like entirely self-service. And in a lot of cases, we support up to 100 gig circuits completely on-demand.
Now, telcos are going to, in some cases, have their own fiber and their own infrastructure. They're going to ride on other plants, other fiber plants, depending on a lot of reasons, a lot of things. How do you guys fit into that? Do you operate your own physical infrastructure or no?
We don't put fiber in the ground. We lease fiber from other providers. We partner with a lot of providers in lots of different markets, because being so global as we are, we couldn't be constructing everywhere around the world. So we lease off local providers. But in terms of that, we then operate that ourselves. The way we design the we work very closely with those partners to build resiliency into the network. So every single data center has at least two paths leaving it. We work with them to get KMZs, which is like maps of where their fibers go. So if we're buying from two different providers on those two different paths, we get the maps from both of them and make sure those paths don't cross. We go to the depths of understanding, is the fiber buried? Is it aerial? Like all of those things to make sure that the network is as robust as it can be.
So what are some of the use cases that people then are typically using everything you've built out for?
So many things. Kind of because we've built the product in a way that you can stack it up in to solve your own problems, I guess. And some of the other things that we do that I kind of missed before is we do internet, so dedicated internet as well, and we run some internet exchanges around the world. So we've got customers who connect to us to do basically global WANs to connect all their data centers around the world. They use that to connect to cloud providers so they can bridge those data center networks with clouds. One of the reasons we built the cloud router product, which I think we're going to talk about more today, is because we were kind of attending some of these cloud events with customers, and the pure play SaaS kind of offerings, they don't have data centers, right? Like they're in like, AWS and Azure. And the costs for getting data between the two cloud providers or even between two regions in the same provider is sometimes pretty prohibitive if you're talking at large scale. So that's where the cloud router was born. The ability to connect those cloud regions without necessarily having to have a data center of your own.
You guys are based out of Australia. It's as evidenced by your accent. So do I care about that if I'm in North America?
Not really. I mean, I hope not. So we're in an interesting position in that we are an Australian company headquartered in Australia, but the vast majority of our revenue comes from North America. And we're listed on the ASX, so this is all public information. But we have a global operations and customer support team. So we have a large customer support team who pick up the phone, answer calls, answer emails. Like a SaaS product, you can chat with us in the portal as well. And we have network engineers and support all around the globe. So anytime that you need us, you can call us.
So I don't have to worry about Australian time zones if I need a support call.
Definitely not.
Yeah. Related to where all you're deployed, you're in a bunch of different data centers. Do I need to be in one of those data centers where Megaport has a presence in order for that to make sense for me?
Not necessarily. So we can do local loop as well. We currently partner with a local loop operator in Australia who's providing dark fiber to like office premises, HQs, like branch offices, things like that. The reason we partner with them is very interesting because they're API driven as well, so they fit into our model quite well. We're working with other partners around the world to offer a similar kind of product as well, where it makes sense for us. Net result, if you do want access in a branch, we can help.
Okay. So, I mean, it could be that I'm in a metro area and there is some kind of a fiber plant that comes into where my offices are. And it could be you're partnered in that area with someone that will supply that last mile to me, get me from there to wherever you are in the city, wherever your major presence is. And then I'm on the Megaport network at that point.
So another option that we have in this space is our Megaport Virtual Edge product. So if you've got an SD-WAN network, like I think a Cisco Virtela, Palo Alto Prisma, you can deploy at those edges on our platform as well, and then bridge your WAN deployment with your Megaport network. So that's a way customers are doing that to get cloud access and things and access to their data centers to that WAN.
Just basically, I'm tunneling to effectively what would be the nearest Megaport POP, something like that.
Exactly. Yeah.
Yeah, that's a pretty common SD-WAN model too for a lot of SD-WAN providers that have their own backbone they want you to ride. They'll put some kind of a box at your premise. It tunnels to nearest POP and then you're on. Then you're on their network and go. So it sounds like the same model.
Exactly. Yeah, we can play middle mile for a lot of those SD-WAN players.
Yeah. So if I stand up a Megaport circuit, let's think of this in terms of WAN, the telco kind of a play. What sort of a service am I getting? Is it like layer 1 dark fiber? Is it layer 2, layer 3? Is it private? Is it internet? Is it all of those things? Something else?
The building block nature of the product kind of means it can be all of the above. So except for dark fiber, obviously. But when you plug into our network, you can choose whether you want an access port or a trunk port. So like, you were playing with our cloud router product, but if you bought a Megaport product, you can choose whether it's like an access or trunk, so tagged or untagged. And if you choose the tagged option, then we can deliver multiple connectivity products to the same physical port, just on different VLANs. So you could say, connect to a couple of different clouds on VLAN 101, 102, take a dedicated internet service on another VLAN. And then if you wanted to connect some other DCs around the world, you could just connect all of those on just different VLAN IDs, basically. And it's all layer 2 point-to-point connectivity, except obviously the DIA, which is layer 3.
So, okay, but you're providing me a pipe, basically. A pipe. And what I stand up on either end is really up to me. So, it isn't dark fiber, but it functions that way, practically speaking.
It's pretty much how we've tried to build it. So it's as close to a very long fiber cable as possible. Yeah.
Yeah. Okay.
What are my bandwidth options?
So we can do ports at 1, 10, or 100 gig. For 400 gig, watch this space. We're and in terms of the connectivity, anything from 1 megabit up to 100 gigabits. So we're very flexible. The portal has all of the options for this kind of stuff. You can kind of just choose from a slider. We also offer like the internet exchange, so where you're in a metro, you can peer with local content networks and the ISPs who peer on IXs as well. We also offer link aggregation groups. So when you're ordering a port in the system, you can choose to put it in a lag. We support diversity zones. So in a lot of our data centers, we have red and blue devices. So you can have ports across different diversity zones. We guarantee that they won't go down during maintenance. The same applies for our VNF products as well. So the cloud router and the virtual edge.
What kind of flexibility do I have with contracts if I'm getting a circuit from you? Is it a year? What if I don't need it that long? Say I just need it for a shorter time for a migration or some other thing. Can I do that? Or is it kind of like that telco model you referenced earlier?
Everything's on demand. So you can have a service for as short a time as you want or as long a time as you want. We do support terms and there's discounts associated with terms. But month to month is definitely something we support. And we see a lot of customers using us for migration use cases or all sorts of things.
So is month the shortest term, or are you willing to be flexible on that?
We call it month to month, but it's actually prorated. So yeah, you can go shorter.
Okay.
We actually, because of the intent to try and model the consumption, or make the network consumption based and on demand, is even if you buy a service on a term, so say you take a 10 gig, you've got 100 gig ports, you take a 10 gig connection on a 24-month term because you're replacing a telco service and that's just how you buy. But you've got a short-term workload and you're like, oh God, I need 30 gig for the next 2 weeks. You can scale up for the short term. You don't have to recommit for the rest of the term at 30 gig. You can just do that as you need.
How are you guys doing privacy? Because, okay, see, it isn't dark fiber, although it might feel like, as you put it, a long run of fiber from whatever the endpoints are you're connecting. So what's actually happening under the hood? Is it like an MPLS core with a layer 3 VPN service? Are you encrypting traffic in flight? What's actually happening here?
That's kind of where I do say it's comparable to a telco. So it's segment routed MPLS, EVPN. Okay. It's from an underlying network perspective and the protocols in use, it looks a lot like what you'd expect from a traditional telco network.
You said SRMPLS, so segment routed MPLS. So that's how you're actually moving traffic for that virtual circuit between whatever the endpoints are that I've stood up. You're building a segment routing stack, and then that defines what my circuit is. Okay.
Exactly, yeah. So if it's from a technology perspective, it's pretty much pretty standard. We're not reinventing any wheels here. We're just automating and orchestrating the provision of the network.
And what about encryption?
We don't do encryption out of the box. We're transparent to it. So obviously, like anything layer 3, we're transparent to. So TLS, IPsec works fine. We'll carry MACsec in a lot of use cases. It depends on the use cases, but we're transparent to MACsec in many use cases as well. So depending on what you're trying to do, there's usually a way to solve that.
Yeah, because you're putting a label stack on top of it. You kind of don't care. Yeah,
exactly. Yeah, it's interesting. We're hearing a lot about MACsec at the moment. Pretty much we deal a lot with financial customers, and MACsec is bread and butter at the moment. So particularly when we're talking about cloud on ramps, it's something that we are working very hard with the cloud providers to support.
There's a demo on your homepage, and your CEO walks through the Megaport UI, stands up a bunch of circuits in real time while he's talking about it. The video's like 2.5 minutes or something like that, and all this stuff's actually happening in real time. And the thing that caught me was, the point of it was, look, GUI, click, magic happens, which is cool, but it made me think, okay, the automation under the hood has got to be absolutely spectacular. Does that mean there's automation that if I'm an automated shop, I can take advantage of that? There's like Megaport APIs I can call and bring into my own workflows.
Absolutely. Yeah, everything we have is based on API. So everything that you can do in the portal, there's an API for as well. We also have a really fully featured Terraform provider. So for customers that are already doing IAC with cloud environment, we slot straight into that stack. We've had the Terraform provider for a really long time, actually, but in the last 12 months or so, we've really doubled down on investing in it because we've got a lot of customers using it. And it was always near the top of the feature request list whenever I met with our customers. So the Terraform provider is a great way to get started with automating our platform. And we also have a great docs portal at docs.megaport.com, which has got a lot of coverage on the API and how to use it as well. And some examples for using Terraform.
Do you have a lot of customers wanting to consume your Terraform?
Yeah, in short, it's very popular, which is great to see. I think coming from, a network engineering background where everyone's typing commands under CLI, it's really, really interesting to see the pivot into IAC for networks as well as, cloud resources and compute.
IAC being infrastructure as code.
Yes, sorry.
Paradigm leap, the change is hard, but once you get past it, then you never want to go back. Yeah.
Yeah, definitely. Yeah, it's really, really cool to see. And we're also trying to add more features in kind of this space. So we've got a beta endpoint at the moment for ingesting metrics from your network into Prometheus. So customers can just point their Prometheus instance at us and get that into whatever network monitoring system that they've got. We're trying to kind of make it so our network fits into your existing tooling without having to kind of relearn a whole new stack to get on board.
What about IP addresses? Can I bring my own? Can I get IP addresses from you?
Yeah, for our internet product, you can bring your own, or we can allocate addresses if you need us to. If you want to run BGP with us for failover or HA, because of the fact that we want to be a good internet service provider. If you bring your own address space, we don't automatically provision that. The system's all automated under the hood, but we vet to make sure you own the addresses. You're not, hijacking someone else's prefix, things like that, to make sure that the service both runs well for you and all of our other customers as well.
How are you vetting? Do you support RPKI or something?
We do RPKI. We typically request LOAs from customers for address space, and we just manually check. I'd love to be able to automate this, but it's not something that the infrastructure exists for quite yet.
And V6, do you support V6?
Yes, absolutely. We definitely support IPv6. Every service gets IPv6 by default. Unfortunately, not all customers configure it based on the down BGP sessions we have, but I would like to encourage anyone listening who uses Megaport to configure their V6 neighbors, please. We'd love to see it.
We're at above 50% adoption worldwide, so
we're getting there.
Finally bending that curve.
Here's a weird question for you, Cam. If I'm running not IP because I got some weird something that's just not running IP, could I actually carry that across a Megaport link?
As long as it's inside an Ethernet header, yes, definitely.
Okay. So Ethernet's you don't care what it is. If it's an Ethernet frame, you can carry it.
Pretty much, even to the point. So obviously MaxX's got an interesting framing format, which we carry. If you have a point-to-point untagged service, so it's untagged at each end, basically, so we don't look at the VLAN header, I'm pretty sure we carry LACP if you wanted to get particularly weird. I think they're pretty much the only things we don't carry is pause frames. Anything else, there's kind of a way to squeeze it through the network if you need to.
All right, I'll ask you something even really weird. How do you handle in an IP header DSCP bits, ECN bit, these kind of things? Do you honor those, strip those? How do you deal with it?
So in the IP header, we don't even look at it. Basically, we don't support different QoS classes across the network. And the way I usually explain that to customers who ask those sorts of questions is if you would like me to prioritize a frame, give it to me first.
Okay. In other words, on my egress, I have to prioritize what's going out. So I would need to play the game of creating, like if your bandwidth is lower than what I am, I've got to create artificial congestion and then have my own queuing and to send it to you.
Yes. So on that, I kind of what was worth covering is so all of our services, even though they're Ethernet based, we guarantee, like we have SLAs on bandwidth guarantees, and packet delivery guarantees. So if we've bought a 10 gig service from us, you should get 10 gig. And if you're not, call us as a problem. So in terms of that, the only time you would really need to be concerned about that is if, you bought, say, 1 gig from us, but you at some point trying to squeeze 2 gig through it.
Okay. Yeah, I've had to play these games before where I'm going to send it to you all day, but I'm never going to see the congestion. It's only going to look congested when it gets to the other end. And so in order to prioritize what I want to happen, create my own packet shaper on egress and then prioritize from there.
It is a nuance, but we police on ingress. So we don't shape on ingress, we police. It's a bit different.
Ooh, so mean. So mean. Okay. Okay, Cameron, I'm a financial services provider, let's say. I have very specific latency requirements. Can you help me with that?
In some cases, yes. So low latency networks, particularly when you're talking like, financial and HFT is a very specific game to get into, and you kind of have to go all in. You can't do half and half. And so I don't think there's anyone running high frequency trading over our network, but we do have a couple of specific routes that we can sell that are better than average latency. So that's more like long haul, short paths. But again, it's not our bread and butter. It's something that we can do, but it's not something we do often.
It's a weird play, right? You'd have to be present where the data feeds are that people want to access and be able to offer a very specific latency profile. And I mean, and those guys get into how long are my service loops? And we got to make sure everybody's even because nanoseconds matter. So
Yeah.
I didn't know if you played in that space or not. But.
No, we do. So we don't play in that space, but we do work with a lot of financial services companies. So we actually even have a product around it called our Financial Services Exchange, which is basically allowing customers to connect and subscribe to services like via aggregators, like what you're talking about there, but definitely not the latency sensitive feeds.
Okay.
I mean, they probably can, but they would not have competitive advantage.
Now, you guys have something called the Megaport Cloud Router, which actually I was playing with just before we got on this recording. Network engineers, we tend to focus on circuits, bandwidth, and latency when we talk about WANs. That's the primary thing, and we tend to bring our own gear. I'm going to put on either end of the circuit some bit of kit that I own, and so on. But you guys have virtual network functions, VNFs that you deal with, including the Megaport Cloud Router. But before we talk about the Cloud Router specifically, what are the VNFs that you offer?
Yeah. So we've got a couple of products in this space. We've got the Cloud Router, and we've also got a Virtual Edge product, or MVE, for a challenging to remember acronym. The Cloud Router is a virtual IP router that we completely manage on your behalf. So it's completely automated and it can be configured through the portal or API or Terraform. This one is effectively the easy mode button. So we'll auto address links. We've integrated with cloud providers, so you can just like connect to like an AWS and everything just magically works. It manages BGP peering. It supports NAT. It supports prefix filtering and a few other things if you want to go into a bit more depth on that. And a couple of weeks ago, we even launched support for up to 100 gigabit cloud routers, so we can kind of do this at scale as well. The other product, the Virtual Edge, it started out as a virtualized SD-WAN appliance, so like Viptela, Palo Alto, Prisma, Aruba, things like that. And the use case was for customers to deploy that virtual edge on our network and be able to bridge their WAN into their data center or cloud environments. But we've expanded that set of VNFs or virtual functions, and we're constantly expanding the list of the images that we offer. And one of the more common use cases that we see these days being deployed on that platform is virtual firewalls. So we support Fortinet, Palo Alto, and Cisco firewalls, and we've got some more coming. And we see customers using these to secure and kind of managed east-west connectivity between clouds and north-south between data center and clouds.
So a customer brings a virtual instance of a firewall from their provider, and then you just run it for them.
Yeah, exactly.
Okay, but they would continue to manage it through the provider's portal and so on, not yours.
Exactly.
Just running it.
Okay. Yeah. And so the VNFs are kind of deployed on, and we deploy and operate compute in a lot of the data centers and where we have network, and it's just generic x86 servers running a hypervisor, and we deploy the VNFs on that. So running virtual network functions is a bit different to normal traditional virtual machine workloads. DPDK and like those sorts of things require some arcane knowledge to make them work well. So we had to go into a fair bit of depth on that to get the 100 gig out of our Cloud Router product. In a way that we can deliver 100 gig to multiple customers on the same box.
Yeah, that was my next question, because you said 100 gig and I was like, yeah, but can I actually pump 100 gig through the thing? And it sounds like the answer is yes.
Yeah, definitely.
Okay. Can you talk about the bare metal a little bit more? What you've got in this thing?
Pretty much an x86 server. There's not a lot of like the secret sauce is in how we configure it in the software. The hardware's so it's Intel CPUs, memory disk, 400 gig NICs. Yeah.
Okay, so it's an x86 box. It's got a 400 gig NIC in it. It's a box. We're used to this. We kind of know with Linux and DPDK and SRVIO and VPP and various other technologies that enable us to get very high throughput from these boxes, so that you can fill a 400 gig pipe and so on. All right. Well, you're standing up, I presume, a bunch of VNFs on bare metal. So we've got a noisy neighbor problem. How do you deal with that?
Yeah, that's a good question. There's lots of tricks and arcane secrets in making VNFs work effectively on x86 in this kind of way. And a lot of it's kind of related to how the network functions are scheduled across the CPU cores and making sure the cores have sufficient PCIe bandwidth to the NIC. And without going too much into the secret sauce, this is something that we think about a lot, and we actively manage it to ensure that noisy neighbor problems don't happen on the platform.
Okay.
I feel like we've had a lot of these conversations 5, 6, 7 years ago around, as software-defined networking was emerging. And I guess what I'm taking away here is that it didn't turn out to be that SDN was something that, sort of the end network engineer was using, but organizations like Megaport have embraced it and are then offering to you as a service.
Yeah, it's a it's a super interesting space. Like software-defined networking and networking in Linux is something that, I'm personally very interested in. As a company, we're very interested in because we play in this space quite a lot. And I think there's a lot of still a lot of unexplored areas here that we can work on from a product perspective over the next few years.
Mhm.
I'm a network engineer designing my network. I'm leveraging Megaport. I'm used to my cloud router from my vendor of choice, but now I've got this Megaport cloud router VNF option. When do I pull that out of my toolbox?
Most of the time we see customers, I mean, so we originally built this product to service multi-cloud use cases. So where customers are consuming multiple different clouds or multiple regions in the same cloud, and they want to connect between them without going over the internet. That kind of helps. We can deliver, in many cases, better latency. There's private connectivity. Those cloud provider direct connectivity products that bridge into our network have different egress cost modeling compared to the internet. So there's definitely cost perspectives as well. But the multi-cloud use case and cross-cloud use case is probably one of the most common. We see a lot of customers with like a hybrid environment as well. So where they've got a cloud router between multiple data centers and multiple clouds, and then they have a data center in the mix as well. So they can create a network between all of that. And some of those use cases are kind of interesting where, to use a US example, say you've got a DC in like Omaha, but you're using cloud regions on the East Coast. Instead of hooking everything back to your DC in Omaha, you can put an MCR in Chicago or Secaucus, keep the cross-cloud traffic local, and just hook everything back to Omaha that needs to go back there. So you're kind of creating these network regions without having to go and build a POP on the East Coast.
Yeah, when I was again playing around with the cloud router before we started recording, was one of the things I was noticing is like I can just take this thing and I can plumb it anywhere that you have presence. There's a whole list of connection options that I have, and it just gets stood up
Yeah.
again in a matter of minutes. It was pretty quick. So you kind of it kind of hit me like, okay, right, not all of this is going across the internet, and that's the point. So I can stand up a cloud router. It could be connected to my Azure network, and then I can plumb over to AWS presence and plumb those through the same router if I want to.
Yeah.
Doesn't go over the internet. And now, I mean, I've got more plumbing to do, but effectively, I've got a path now to connect those two environments.
There's slightly more plumbing to do, but also at the same time, there's some pretty big cost savings to be had, particularly when you're comparing the egress cost with cloud with the egress cost over like the direct connect and express route type products. And I don't have the numbers in front of me. We've done a lot of modeling on this, obviously, because it's part of our sales pitch. And the break-even point is probably lower than you might think from a traffic perspective.
No egress costs. Okay, actually, help me with that one. So what's going on there?
There are egress costs, to be clear, but it's different. It's a different model. So I'm not going to quote numbers because then the podcast goes stale. But if you're egressing to the internet from a cloud provider, they'll charge you so many cents per gigabyte transferred. If you're egressing traffic over like a private connectivity from those clouds, the cost per gigabyte is less, usually
Okay.
less than half.
So there's actually an ROI there with building
Yeah,
out with this
definitely.
model. Yeah.
Yeah.
Okay. Yeah. Intriguing. What can I, for routing protocols, what have I got with the MCR? Is it just BGP? Do I have other options?
So we support traditional IP routing, static routes, and BGP. So if you're using BGP,
Yep.
we also support things like prefix lists and some basic traffic engineering like MEDs or multi-ex discriminators, and we can do AS path prepending. And we support BFD for fast failover on the BGP sessions as well. We don't support any IGPs, and because it's fully managed, we don't let customers kind of access the VNF directly via SSH.
So I was wondering about that because I looked, it's like, oh, I want to see the CLI. I know I'm not supposed to need it, but I just want to see. But but
Yeah,
there's not there at all.
the point is that you don't need it. Yeah, exactly. And so the point is, yeah, it's like it's fully managed. So we have some plans to add some more telemetry export type things, which I kind of talked about a little bit earlier, to help customers integrate it more neatly into their existing monitoring stacks. But the point with the BGP support is it's really around making it easier for people to connect to the cloud providers and connect their data centers. We support all of kind of like the obvious choices, but if you wanted to go particularly bespoke or do something overly tricky, then that's kind of when we start to talk to customers about, okay, like is MCR right for you, or should you be looking at a virtual edge platform where you can run up your own router and do your own things?
Can you talk a little bit more about the telemetry you're providing and how you provide it? Because I guess on the positive side, making it easy for the customer is great, but I'm sure there are customers out there who are like, well, if I can't get under the hood, I can't really feel confident about, troubleshooting or SLAs or anything.
We currently have a beta endpoint for exporting to Prometheus and Prometheus format. So a lot of like big NMSs like uh, support ingesting data metrics in that format. So we support that, and customers can integrate that into their existing stack. Something we don't have today, but it's something we're looking at adding, is things like IPFix, so flow exporting, and BMP and other monitoring protocols to help customers get that deeper level of visibility into what's happening on the network. That kind of ties into the security story as well. Those typically get ingested by SIEM systems, and then customers can get that like overall visibility and replay and detailed analytics into what the network's doing.
You mentioned BMP, BGP monitoring protocol, which we did a show on that pretty recently, and it's kind of, I mean, it's been around for a bit, but it's also somewhat emerging. I don't know how many people are using it. Are you getting customers asking you for that?
Yes, not many, but particularly in the financial space, we do get customers asking for that
Oh,
because they want to be able to replay what's happening on the network and get really deep.
So how do I actually get traffic into the cloud router?
We do see customers service chaining the cloud router with some of our edge products like firewalls, but most often customers are just terminating virtual cross connects, so which is our circuit product directly on the MCR. So similar to how if you had a port in a data center, you can deliver different connectivity options on different VLANs. You can do the same thing with the cloud router. So once you've got that cloud router, you can order like a dedicated internet on VLAN 10, data center interconnect on VLAN 20, and a cloud connection on VLAN 30. And then it will we automatically provision the sub interfaces for each of those. And then you just put IP addresses on it and it behaves like a normal router. And going back to one of the previous comments, yes, it does support IPv6.
Well, you say virtual cross connect. I mean, if you're in Equinix and I'm in the same Equinix data center, a cross connect would typically be a physical cable, but there's no physical cable here. So what are we talking about? Some kind of a tunnel?
Point-to-point circuit. So this is basically our bread and butter product, where if you're in a Equinix and someone else is in a Digital Realty, you can use us to connect between them. If you both happen to be in the same data center, we can still help there too. This kind of ties into our ecosystem story, really. So obviously, if you're a Megaport customer, you can use us to build a global backbone for your own network. But if you're a Megaport customer and I'm a Megaport customer, you can also use it to connect to me. And so that kind of ties into the financial services exchange that I mentioned before. We see customers using it to pick up transit from other networks. We see customers using it to connect to like emerging clouds, or I heard a term the other day, micro hyperscalers, which is interesting. But some of the other service providers.
No, don't. That's not a thing. Please tell me that's not a thing.
Words have to mean things, please.
Yes, but yeah, it's you can like, I mean, obviously we from like the more telco side of our product is people building their own networks over us, but we also have this whole ecosystem where you can connect to anyone else over us, and we have a lot of features in the product around generating service keys and the ability to connect to third parties and have those third parties kind of facilitate that connectivity. So if like you're going to buy a service off me, I can go into my portal account, I can generate a code on one of my access products like an MCR or a port. I can send that code to you. You can go to order a connection, you can put that code in, and the magic just happens.
I was wondering what that field was for, and I was like, what's the service code thing? And I didn't get as far as like digging through the docs to figure that out. So that explains it. It's very interesting. So it's like you're an IXP, but you also connect to IXPs as well. I noticed in my connection options, there's a whole bunch of IXs listed.
So we operate our own exchanges in cities where it makes sense to, and where there's like a hugely dominant player, like a Lynx or an Amzix or something like that, we offer connections to them instead. So we partner with them and we've exposed them in our platform too.
So, okay, so I kind of think I get the use cases here, but just to sum it up, I mean, when am I deploying? Why would I deploy an MCR, a Megaport Cloud Router, instead of a similar virtualized offering from, I don't know, Cisco or somebody?
It really just comes down to the simplicity, I think. So with the MCR, we manage everything for you, whereas we can still help you deploy like a managed like a virtual Cisco router, like a C8000V. But then you would have to manage all the config as well. So if you're using an MCR, you don't have to worry about config backups. You don't have to worry about losing access to the device if you fat finger an ACL. or kind of managing the software licensing or software lifecycle stuff. We do all of that for you.
Cam Daniels, CTO at Megaport. This is a fun conversation, man. Thanks for letting us get a peek under the hood, and thanks for setting up the account so that we could actually play with this a little bit and get a sense of how it all works. It was I had fun for the hour before we recorded this, and I have cloud routers to go tear down now that this this recording is over, so they're not sitting there burning up CPU in a data center in New York City. Where can folks find out more, Cam?
Megaport.com/packetpushers. We've got a site set up to kind of tell everyone what they need to know about the platform and get them on board. So anything you need, just jump over there.
Great stuff. Thanks to you for listening today. And remember that Megaport has free merch for you if you are based in the US. Go to megaport.com/packetpushers, as Cam just said, and claim your t-shirt with promo code packetpushers. Again, megaport.com/packetpushers with promo code packetpushers. And if you do that, remember that helps us pay our bills. Megaport's going to know you're listening and you're interested, and then send us more nerds like Cam to talk about global WAN engineering. I have been Ethan Banks, along with Drew Conway Murray. You can hear us each and every week right here on the Packet Pushers podcast network that exists for your professional career development. And we will see you on LinkedIn, Blue Sky, and the Packet Pushers community Slack group. You can find out more about that Slack group at packetpushers.net/community, and check the footer of our website for ever more ways to connect, including IRC and even Strava for you health-minded folks. Don't forget megaport.com/packetpushers. And last but not least, remember that too much networking would never be enough.